Okay, everybody, I hope you're ready to take our factoring to a new level. I just want you to right now realize that we're going to spend 2 days on this. I'm going to do the whole film today, but that doesn't mean you can't come back and watch parts of it. I'll also be putting out a notes page that's filled in as usual. Today, what is going to change and why we're going to kind of kick it up a notch is when we go to factor our quadratic trinomial, the a is now no longer just going to be the invisible 1. So as you can see, these quadratic trinomials that are showing up here, things are going to get a little more complicated by putting a number other than 1 out in front of the squared term. So let's start just like we did in the last video and pause the video and FOIL these to get, in this case, 4 quadratic trinomials. And once you've got them, turn the video back on and we'll see how you did. Okay, guys, so let's see. When you FOIL, did you get 2y squared plus 11y plus 5? 3y squared minus 5y minus 2? And 6y squared minus 13y minus 5? And finally, 3y squared minus 10y plus 8. If you are having any difficulty here with foiling, please send me an email so that we can kind of fix that up. And I'm assuming at this point that everybody can FOIL 2 linear binomials and come up with a quadratic trinomial. So today, again, what we're going to do is be given the answers and asked to factor to get back to what we started with. Easy peasy. We did it in the last class, except this time there's a number out in front. So in the 2 binomials, we're not going to have y times y. We're going to have 2y times y, or 3y times y, or oh no, this guy's not prime. Is it going to be 6y and y, or 3y and 2y? And all of a sudden, we start seeing there's all these possible combinations. There are 2 things that are going to kind of be your BFFs. The first one are prime numbers. Because if the number is prime, like 2, 5, and 3, and 5, those are all going to just have a combination of 5 and 1. But the minute we're dealing with a non-prime, we've got choices. Is it 1 and 6? Is it 2 and 3? With 8, is it 1 and 8? Is it 2 and 4? You're going to hate the number 48, and even more, you'll hate 96 because there's so many combinations. But let's see what we're doing here. Let's start with this example. So we're going to be factoring ax2+bx+c, and a is going to now not have be a leading coefficient of 1. So we're going to start with letting the c be positive. And you need to remember from our last lesson that if the c is positive, then both of your linear binomials have to be pluses or they both have to be minuses. Because when you FOIL that last term, L times L, the constant times the constant, to get a positive, they have to have the same sign. Now the next good news is that that sign right there, that operation is telling you that we need 2 pluses. If these were a minus and a minus, then that would give us a negative b here. So we know that these both have to be plus. But today, we've got to take into account the fact that we've got a 3 in front. So what I like to do, this guy is prime. I only have 1 possible pair, so I'm going to put them in and I'm going to lock them in. I'm not going to move them at all. Here are all the possibilities that could have multiplied to a positive 8. We already know that this pair and this pair are not going to be possibilities because of that positive b. So it's got to be one of these 2. So I'm going to put the plus 1 in the first binomial. I'm going to put the plus 8 here. And I just want you to see how this 3 is going to have an effect. I'm just going to check the OI, the outer and the inner, to see if I get the 14. So when I take 3 times 8, I'm going to have a 24x on the outer and a 1x, which would make 25, and that's not the 14x. Before I throw this pair away, however, I need to switch them because that 3 out in front is going to have an effect. So notice when I multiply it in this order, I'm going to get 3x plus 8x, which is 11x. it still doesn't work, but you do have to check kind of in both directions. So let me get rid of that pair and let's bring in the other pair. So if we have the +2 going combined with the 3x and the +4 combined with the x, will we get the +14? I'm going to check the O. 3x times 4 is 12x. The I is 2x, and sure enough, 12x plus 2x is 14x, and I think I have the winner. I'm going to remind you, first of all, it doesn't matter which order you write the binomials in. So if you wrote the x plus 4 in front, that's the same thing by the commutative property of multiplication. The other thing I want you to remind you is the last thing you should do when you're factoring is to FOIL it back to check your answer. You actually know whether you got 100 or not by FOILing. So first would be 3x times x, which is 3x squared. 3x times 4 would be the outer, which is 12x. 2 times x is 2x. 12x plus 2x is 14x. And the last would be 2 times 4, which is 8. And I'm happy girl. My factoring is one linear binomial being 3x plus 2, and the other one being x plus 4. So why don't you give it a try right now on the first one? Just pause the video and just try A. If you're stuck, come back and I'll give you a hint to get started. Okay, for the people who needed the hint, notice that you've got an 11, which is a prime number, and you've got a 3, which is a prime number. But that 11 right there is going to tell me that I'm going to put an 11W and a 1W, and I have no other choices. Because the C is positive, both of these have to either be both plus or both minus. And since the B is minus, they're both going to have to be negative. So if you needed that hint to get started, pause the video and finish the problem. Okay, everybody's back. So now I only have one choice. Thank goodness for prime numbers, right? So I have to put a 3 and a 1. One way or the other. Now notice if I put the 3 on the outside here, I'm going to be multiplying by 11. I'm going to get 33. And if I put the 1 here, I'm going to get 1, and I'm not going to get the 14. So I'm going to put the 3 over here and the 1 over there, and let's see if that works. Let's FOIL it and check. 11W times W is 11W squared. The outer is negative 11W. The inner is negative 3W. Negative 11 combined with negative 3 will give me the negative 14 with the W. And a negative times a negative for my last would give me a positive 3. This is the factorization. Okay, so before you get started, we're going to pause it again. Remember what I said and see if you can just set up the beginning of it right now. Okay, just having done that, did you put a 2W and a W, and did you realize that since the C is positive and the B is positive, both of these have to be positive? So now you're going to come out and you're going to look at the 12. Should it be 1 and 12 or 12 and 1? Should it be 2 and 6 or 6 and 2? Should it be 3 and 4 or 4 and 3? Pause the video and see if you can figure out which combination is the right one in the right spots. Okay, let's see how you did. Okay, of course, once you see it, it's like, oh, there it is. So if you were having trouble, that's the problem with factoring is once you see the answer, it's kind of a done deal. So 2W times W is 2W squared. The outer would give me 8W. The inner would give me 3W. 8 plus 3 is 11 with the W. And 3 times 4 is 12. Okay, I'm going to stop and just let you handle the next one. This time you have a little bit of choices on the front. Is it going to be 3 and 3, or is it going to be 1 and 9? You also have choices on the back. Is it going to be 1 and 4, or is it going to be 2 and 2? See if you can find the two linear binomials that would multiply to this. Pause the video and give it a try. Okay, you might notice that this is the identical twins, and if you remember from a lesson last week, we talked about multiplying the identical twins and what happens. You're just going to notice, you're going to see in front of the t squared, do you see the 9? And do you see the constant? Do you see that those are both perfect squares. This is 2 squared and this is 3 squared. When you notice that, it's often the best place to start with the identical twins. And of course, we're always going to check it in case the middle isn't what we need. But 3t times 3t is 9t squared. The outer is going to be 6t, and the inner is going to be 6t. And the last is going to be 2 times 2, which is 4. So notice that when I multiply the 3t times the 2, I get 6t, and it's doubled in the center. This is called a perfect square trinomial. We'll be talking more about that in the future. You don't have to recognize that yet, but we will be talking about how to do that. The other way you can write that is to write that quantity squared, right, since they're identical. Okay, so let's take a look at this one. Look, the front is prime, 2x and the 1x. The back has got some choices. I'm not going to look at the negatives because they have to both be positive to make this work. And if I kind of put my combinations together, the weird thing kind of happens here. So I'm going to pause and just see if you can find a combination that works. So some of you might have come back and found the 2x plus 6 and an x plus 2. Do you see the 2x squared? Do you see a 4x on the outer and a 6x on the inner, which does make the 10x, and 6 times 2 is 12. Now, there might be some people out there right now going, but wait, I have a different answer. So if we take a look at this combination, we still get the 2x squared. We get 6x on the outer, 4x on the inner, which does give me the 10, and 4 times 3 is 12. And it's kind of weird because we have two answers. Well, the problem is that we have not completely factored this one. So we're going to bring back an idea from about a week and a half ago or 2 weeks, where we talked about factoring out the greatest common factor. And it makes your life so much easier. It is your true BFF. If you look up here, you're going to notice that these are all even. And if we had first started out by factoring out that greatest common factor, pulling the 2 out in front, so making that 2 times x squared, 2 times 5x, which will give you the 10x, and 2 times 6, which gives you the 12, we now have a much simpler quadratic trinomial to factor. Now that 2 is just going to come along for the ride. He's going to be part of your answer, but now you're going to create 2 sets of parentheses, and this is actually the last section's homework. Notice the a is 1. This is an easy one to factor. So what I want you to do right now is write the number 2 and 2 empty sets of parentheses and factor this one out. And pause the video and come back and let's see how you did. So when you factored this one, you needed 2 numbers that multiply to positive 6, and notice this plus, so they're both going to be positive. So I'm thinking either 1 and 6 or 2 and 3. Which pair adds to 5? The 2 and the 3. And here is my final factorization. So if you were to write one of these 2 answers, you're actually not completely at the right answer, because notice here, there should have been a 2 factored out, or look over here, there should have been a 2 factored out. And the 2 comes along, like I said, for the ride. It's part of your answer. When you're checking this, you're going to first start by foiling the 2 binomials. So when you want to, foil this, and you should get this, and then you have a second step of multiplying that 2 back in to make sure you get back to what you started with. But your final answer is right here. That's the completely factored version. So here's one just to see what I mean by completely factoring. This looks nasty until I realize that there is a common factor in all of these of 7. So I'm going to take that 7 and factor it out. 7 times 3b squared is 21b squared. 7 times negative 10 would give me the negative 70 with the b attached. And 7 times 7 is 49. And now I'm going to go the step further. Write the 2 sets of parentheses. I've got a 3b and a v. And ooh, this is prime 2 and a 7 and a 1. And I've got to find out the right combination. The 7s you're just going to write down. And then we're going to write 2 blank sets of parentheses, but I'm going to put the 3v and the v in because it's prime. There's nothing else that can happen, and I'm not going to move them. Now, both of these have to have the same sign to get a positive, but since that's a minus, they're both going to be minus. So now the last thing I do is I look at my number here and say, okay, what combinations multiply to 7? And because it's prime, it's only 7 and 1. So the last question is, do I put the 7 here with the 1 there, or vice versa? Stop the video, write them in, and come back, and we'll check it. Okay, did you get the right ones? Let's see. Drum roll, please. All right, let's see. We're going to check this one by foiling it. So 3v times v would give me the 3v squared. The outer would be negative 3v. The inner would be negative 7v, which would add to a negative 10v. And a negative times a negative would give me the positive 7. Now the second step is to multiply the 7 times the 3v squared, the 7 times the negative 10v, and the 7 times the 7, and you'll see you get back to here. So what's your final answer right here? That's the completely factored form of this quadratic trinomial. Okay, one last thing for today, guys. Let's make the c negative. Now remember that when the constant is negative, we're going to have 1 plus and 1 minus. So they're not going to have both the same sign. And really, you're going to look at him as to which one should be negative in order to make the right number there. We got some choices here, so it is a trial and error. So this is how I go about it. First thing I do is I look for a greatest common factor. There isn't one here. Second thing I do is I write 2 blank sets of parentheses, and then I look to the front. I have 2 possible combinations to get me to the 6y squared. The good news is I only have the 5 and the 1. And again, remember that one has to be positive and one has to be negative. The most important thing is you work in pencil. So I'm going to just start by writing 3y in the front and 2y over here. That will give me the 6y squared. And then I'm going to come over here and I'm going to pick up and I'm just going to write these in and see what happens. And if you notice, I got 3 times a negative 5 would be negative 15, and the inside's a positive 2. So I have negative 15y plus 2y is not going to give me the negative 29y. Now before I throw that pair out, I'm going to flip them to make sure it wouldn't work the other way. So now I have positive 3y and negative 10. And a positive 3y and a negative 10y don't combine to negative 29. So this pair I don't want. I'm going to throw them out for right now. Now the next thing, would it make a difference if the signs were switched? And pretty quickly you're going to realize that you're just going to get the positive or the negative difference. So this isn't working. So the 3 and the 2 are kind of a fail. So I'm going to set this all back. I'm not going to use the 3 and the 2, and now I'm going to put the 6y and the 1y in. I'm going to come in and put the positive 1 there and the negative and see what I've got. Now when I multiply the outer, notice I've got negative 30y and the inner is positive 1. And there's the winner, because negative 30y plus 1y is negative 29y, and I think I've got it. Now remember again that I can FOIL this back to check it. So 6y times y is 6y squared. The outer will give me negative 30y, and the inner is positive 1y. And negative 30y plus 1y is negative 29y. And then a positive 1 times a negative 5 is a negative minus 5, and we are good to go. And there's my combination. All right, let's do another one. Here, like I said, there's 2 things that are going to be your BFFs. One is the greatest common factor, and the second is prime numbers. If you notice here, there is not a greatest common factor. They're not all even, so I can't pull that out. But I am happy because that 2, I don't have a choice on the front. The 2 and the 1 are the only possibilities. But I got some choices hanging out here. One of them has to be positive, one has to be negative in order to get the minus here. And just remember that I've got to get a negative 7. So I just start by kind of putting these guys in. And if you see here, I'm going to get negative 30w and positive 1. No way does that combine. Now, if I was to have the sign switch, remember that it would be a positive 30 and a negative 1. So that pair wouldn't work either. But I am going to switch these before I move on just to see what happens in the other direction. 2w and negative 15w. Negative 15 plus 2 is negative 13. So this guy doesn't work. So I'm going to throw them back into the pile here. And I'm not going to check these, because those are just going to give me different signs. So I'm going to try this pair. What if I went this way? Now if I check right here, notice I'm going to get a positive 10 and a negative 3. And a positive 10 and a negative 3 would give me a positive 7w. This is the right pair, but the signs are wrong. So I'm going to throw those and put in the signs correctly. And I think I finally got it. Let's check. 2w plus 1w is 2w squared. 2w times negative 5 is negative 10w. 3w on the inner, negative 10 plus 3 is negative 7w. And a positive 3 times a negative 5 is a negative 15. And I've got the right combination. And don't forget that the order of the binomials doesn't matter. If you had written the w minus 5 first, you're good. And you also, this 1 can be the invisible 1. Okay, guys, I'm going to ask you to stop the video and give these two a try. We're going to notice that the c's are subtracting, which means you're going to write two binomials right now that are empty, and know that one of them is going to have to be a minus and one's going to have to be a plus. Good news is you got a prime number here and a prime number there, and down here you've at least got one. Pause the video and see what you can do. And when you're ready, start it and we'll see how you did. Okay, guys, welcome back. Let's see how you did. We know there's going to be a 2c and a c on the front. We know there's going to be a 3 and a 1. And we know that they have to be one positive, one negative. Let's see how you did. So 2c plus 1 and c minus 3. Now, please note that that is different than having 2c plus 3 and c minus 1. So the plus 1 has to be with the 2c. The minus 3 has to be with the c. You could have written them in the other order, putting the c minus 3 in front. That would be fine, but they have to be this way, and let's prove it. 2c times c is 2c squared. 2c times a negative 3 is a negative 6c. And the inside we've got a positive 1c. Negative 6 plus 1 is negative 5c. And a positive 1 times a negative 3 is a negative 3, and we are happy. Now down here, the question was, is it going to be 2t and 2t or 4t and 1t out in front? Let's see how we did here. It is the 4t and the 1t. The back at least was easy because it's prime, but let's check it. 4t times t is 4t squared. The outer is going to be 4 times 1, which is 4t there, and the inner is going to be negative 3t. If you take a positive 4t and subtract 3t, that gives you 1t, and a negative 3 times 1 is a negative 3. Okay, the last thing we're going to do here is bring back our other BFF. So look at these. Like, you start to look at these and go, oh no, there's like, 6 and 1 and 2 and 3, and the back has a 9. It could be 9 and 1 and 3 and 3. And you start to feel like, oh my gosh, there's all these possibilities. Remember that the first thing you want to look for is there a greatest common factor? And that completely factor, right? You want to make sure that you have something, if it has a GCF, it comes out. So what I'm going to ask you to do is you're going to pause the video. You're going to look for a GCF. If it's there, you're going to pull that out first. And then once you have that GCF out in front, you're going to look at the result that's in the parentheses. Can you factor that further into two binomials? Now, when I look at D, something's up already. Because do you see that power of 3? When we see that power of 3, if there is not a greatest common factor, getting that C out in front, we don't know how to factor this because we can only factor quadratics. This is not a quadratic, it's a cubic, so it's shouting at you, I think I have a GCF. So pause the video, guys, and give it a try. I'll see you in a minute. All right, what was the greatest common factor up here? All of these are evenly divisible by 3. So 3 times 2y squared will give you the 6y squared. 3 times negative 5 will give you the negative 15y. And 3 times negative 3 gives you negative 9. Do we have a greatest common factor here? We're going to come back. And right now, just looking for GCFs. And between the 24c to the third, the negative 10c squared, and the negative 4c, did you see a greatest common factor of 2c? 2c times 12c squared would give me the 24c to the third. 2c times a negative 5c would give me the negative 10c squared, and 2c times a negative 2. Okay, now the question is, can I factor this further? So the next thing I would do is put the 3 out in front. He's just going to come along for the ride. Write 2 sets of parentheses. I'm really happy right now because these are both prime, and I think I can come up with that combination. Let's see. If you didn't do that, pause the video and try to finish the problem right now. If you're ready and already did that, let's see how you did. So the 3 is out in front. 2y plus 1 and y minus 3 has to be the positive one with the 2y and the minus 3 with the y. To check it, you're going to forget the 3 for a minute, and you're going to FOIL. 2y times y is 2y squared. This is going to be a negative 6y plus 1y is negative 5y, and the 1 times the negative 3 is negative 3. And now if you distributive property and multiply by the 3, sure enough, you get back here. So what's your final answer? That right there is the complete factorization of this original quadratic trinomial. Now down here, like I said, he's shouting at you, the c's got to get out of there. So the biggest number that divides into all of these is 2, and the smallest power of c is 1, so we're going to pull out a 2c. Now when we look at these, he's going to come along for the ride. 12 is tough. Is it 1 and 12, 2 and 6, or 3 and 4? There's 3 possible combinations. Thank goodness the back is only prime, and it's a 2 and a 1. Again, if you had trouble doing this, you want to stop before you move on here. All right, let's see how you did. So when I FOIL these 2 binomials, you'll see the 12c squared minus 5c minus 2. And then I distribute and multiply the 2c back in, and you'll see we get back up to that. So what I want you to hear is the most important thing is practice. And the more you try and the more you succeed and fail, it will get easier and easier. You're training your brain. So just please understand it's practice, practice, practice. And that's what we're going to be doing now and tomorrow on these. And then we'll talk about our special cases, and then we're going to mix everything up. So we have a lot of practice coming. The notes page will be attached to Classroom, and also, rewatch part of the video if it will help you. Guys, practice, 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 and have a great day.